So now I thought we'd go ahead and talk about one of the primary reasons and features of C++ that we're going to be using for the class, and that is something called a class. Ironically, we're using classes for the class, right? So conceptually, you can basically think of a class as a structure on steroids, right? And this will all kind of make a little bit more sense why I say that in a minute, right? So first, let's just talk about how we would have organized data and structures and functions in normal C with what we were given. Right, so if you look at the screen here, we basically have one structure called coordinate here, and it has an x, y, and z axis. We have a sum function, which takes a coordinate as a parameter and returns the sum of those three. And then in the main function, we go ahead and create a coordinate, set the values x, y, and z, and then call a function on it, right? So for this simple example, having a structure and a function that works on that structure, and then basically setting everything manually from main works, right? Because this is a pretty simple structure and there's not a whole lot going on. But if we start getting into more complex structures that have lots of member variables and things need to be set just correctly, we can start running into problems. And the main cause of those problems is kind of the divide between the structure and then the functions that work on those structures. And then also on top of that, because since we are working with a structure, we have direct access to all of the data that's in the structure. So let's say you're a C developer and you develop a special structure that achieves some desired effect and a set of functions that operate on those structures, but the user goes ahead, includes your code, but then starts mucking with the data in the structures in a way that you didn't anticipate or that they just should not be allowed to do. But because it's defined as a structure, they have direct access to everything and they can do as they wish, whether that's a good thing or not. So a class is basically another organization structure that tries to fix some of these issues, mainly dealing with organization and data protection, right? So a class version of this will basically have the data protected in such a way that the user can only modify that data in some way that you approve of, and then have a set of functions that are directly tied to that data so that there's less chance of the user messing up whenever they're using these things. All right, so let's just take a look at how we would transform this structure and function and the associated function calls into something that would look like a class, or what it would look like in a class. Right, so if we're going to define a class, the first thing we're going to do is use the class keyword. We're going to call it chord again, and then you'll have your same opening and closing brackets, and then inside of the class, right, and again, this is effectively a prototype of the class, so a class will contain the data we're working on as well as the functions that operate on that data. Right, so inside of our class, we're basically going to have two sections, a public section and a private section. Anything that is defined inside of this public section right here is going to be callable directly by the user of the class. So if the user imports your code, creates an instance of your class, they can directly call and work with anything that's in the public section. If it's in the private section, that means only some other function inside of the class will have access to that. Right, so you can put both variables and data inside of here to make things work, right? So you can protect the things that need protecting. Right, so for instance, if we were directly translating this class or this structure and function into the corresponding class, we would basically have something that would look like this, right? So the user has direct access to x, y, and z. So we go ahead and put int x there, int y there, and int z there. And they should also have direct access to the sum function so that they can actually call and get values out of our class, right? So we're going to define int sum. But the difference here is we are not going to put any parameters to sum, right? Because this function will have direct access to any of the variables that are inside of the class. And for now, we're not going to put anything inside the private class, but we'll change that in a second. All right, so let's go ahead and delete the old structure and the old function. And what you're going to see is that everything's going to work pretty much the same way it did before. If we just use coord C1, we create an instance of our class, and then we can go ahead and set x, y, and z variables, and then we can call the sum function to get the sum of the various points inside of our class. The difference here is we cannot actually just call sum directly right now, right? Because sum is actually part of the coordinate class. So because it's part of the class, we treat it just like we would treat a member variable, right? So we're saying c1.sum, right? Call the sum function that is inside of the coordinate class, right? That's all we're saying there. And now before we can actually compile and run this program, we actually need to implement the sum function, right? Right now this is just one giant prototype. Now we actually need to implement the functions that are inside of that prototype. All right, so if we're going to define the sum function, which is inside of coordinate, we're going to have something that looks like this. Right? And you're going to notice we need to put this coordinate : in front of the sum function. We need that because this is kind of that whole namespace thing I had talked about. All right, we're saying this sum function belongs to the coordinate namespace or the coordinate class. If we don't have that, then we're going to end up getting a compiler error, right? If I would try to compile this right now, right, we get errors because it says it can't find a coordinate sum, right? Even though we make a call to it in our main program. So to fix that, we just put coordinate back in there, and now everything will compile. Other than the warning, because we didn't actually implement the function yet. So if we want to implement this, all we need to do is return x plus y plus z. Right? And note, we don't need to put like c1 or c1 dot or coordinate dot in front of x or anything like that, because we are a member of that class, right? We are a function that is a member of the class, which gives us direct access to everything that's in the public section and directly everything in the private section, right? That's just kind of how classes work out. So if we compile this again, it compiles and we run it, and we get the sum is 60, which is correct, right? We added 30, 20, and 10 up. All right, so that is your basic class, as the most basic class we can get to. So now let's take a look and see what happens when we move our x, y, and z into the private section and we try to compile this again. All right, now we get these errors that are basically telling us, hey, y is a private member of coordinate. You do not have direct access to that. So to kind of get around that, what a lot of classes do is kind of create these functions called getters and setters. And there's a lot of debate, in the programming world about whether getters and setters are really important or whether you should use them, but we're just going to take a look at them anyways. All right, so I'm just going to create this void setter function, and it's going to take 3 parameters, a, b, and c. And we're just going to use that to set the values of x, y, and z inside of our function. Okay, so we want to define this function again. And remember, because we are defining a class function, we need to put coordinate in front of it. And now, inside of this function, all we need to do is basically say x equals a, y equals b, and z equals c, and we're good to go. And then in our main function, we would change this. So now we're doing c1 dot setter 10, 20, and 30. So now our main program goes ahead, creates the function c1. We then call c1.setter and put 10, 20, and 30 into our class. So we set x, y, and z up with their correct values, and then we can call c1.sum. and actually go ahead, sum up the numbers, and print everything out. So we try to compile it again. Oops, I forgot one bit here. Compile it one more time. Ugh, did I not save? Nope, I'm just blind, I guess. There we go. This time it'll work. Third time. I always get it on the third time for whatever reason. So now we run it, and we still get our sum is 60. Right? So this may not seem very useful or important from this, super simplistic example, but imagine you're working with complex data, and that data needs to be set up in very specific ways. More often than not, you don't want the user setting it up themselves. You just want them to give you the data, and then your code sets everything up correctly, right? That's one of the most important parts. By putting these variables inside of a setter, we now have complete control over how this information is stored or set. Right? Let's say we had some limit on what the user could give to our data, right? Let's say, for instance, x should never be more than 100. Right? We could do if a is greater than 100, then you would just do x equals a minus 100 or something like that to control the data. Without a class or without this setter function, the user could just potentially shove bad data into your structure and then feed that structure into another function, and you would just end up with this cascading failure, which would not be good. So classes basically just give you this more fine-tuned control over what the user can access and can't access, etc. Right? But that is basically, your quick intro to classes. Right? If you have any questions, make sure to send me whatever you might have. We'll get them cleared up, as well as check out the exercises that I provided as well. Right? And the easiest way to learn this stuff is really to be given a task, and then a quick short task, and then go ahead and do it, so that you can kind of pick up what's going on and kind of get some of these subtleties worked out early so they don't come back to bite you later. But with that, that's it for this video, and we'll see you in the next one.